Welcome to part 2 of this video series. In this video, we will construct code projects for both backend and front-end on the local machine. Build the foundation. Let's get started. Now I'm in an empty folder I just created. Let's create two subfolders, one for the backend and one for the front-end. Let's start with the backend. I already have azure-functions core tools installed. I also installed .NET Core SDK, as I'm using .NET as a function runtime. Both look good. Now, let's create a function project. Name it as function backend. I'm going to use .NET as a runtime. Other runtime options are Python, Java, Node, and PowerShell. For .NET, it creates a C# class library project. Go into the project folder. A project file and the local configuration files have been generated. Now let's create a function. A function will run a piece of code when it is triggered by an event. Give it a name, Wigplan functions. We see a list of templates to choose. Because we are going to provide a REST API over HTTP, so we choose HTTP trigger. The function is created. We see the Wigplan functions C# file is added. Now let's start the function. The function is ready now. Its endpoint is available at this URL. Let's give it a go. Copy the URL, open another command line shell. Side by side, clear URL. The function created by the template is expecting a name parameter. On the left side, the function is executed. On the right side, we see the response from the function. Now let's move on to change some code. Terminate the function by Ctrl+C and open VS Code. On the left side, we see the code structure generated earlier. We need to add some data models and supporting services. Let me create one folder for models, one folder for services. To save time, I'm going to copy and paste some code that I already prepared. Let's go through the code I just copied. In the models, we have a class called Wigplan. It's a plain old C# object. It has a few properties including ID, title, and others. I keep it very simple. In the services folder, I added one interface, iPersistence service. It's an abstraction of the create, read, update, and delete operations on Wigplans. Everywhere we use this interface, and so we can decouple from the implementation of persistence service. Because we haven't got a database set up yet, so I create a fake persistence service. It implements interface iPersistence service. Look into the details. When we try to get Wigplan async, we actually call a method getFakeData, which returns some hard-coded data. Review other methods in the class. They haven't been implemented yet. Also, I added a service factory. It constructs a service objects. For now, getPersistence method constructs and returns an instance of fake persistence service. It will be replaced later. I have changed the Wigplan functions from the original one generated by the template. There is only one function at the moment. The function is triggered by HTTP request. We set authorization level as anonymous. It means when we call this function, we don't need to provide any API key. It supports HTTP GET method. Its root is Wigplans. When a request comes in, this block of code will be executed. It gets an instance of persistence service from service factory and then call getWigplanAsync method to retrieve data. If there is some data, it returns the data in the response. We start the function project and see it in action. Now the function is started. We see the function supports HTTP GET method. Also, the route is changed as we specified in the code. Let's copy this URL and test it out. We open a command line shell side by side. Cur URL give the URL of the function. On the left side, we see the function is triggered and then executed. On the right side, the response includes the hard-coded data we defined earlier. Now we have a function running which responds to HTTP GET request. Let's move on to the front end. Nowadays, there are many UI frameworks. In this demo, I'm going to use React. It's easy to learn and it runs fast. However, later you will see the front end is decoupled from the back end, so it's your choice to use what UI framework. If you have used React, likely you know about the Create React app. It's an NPM package help us to create a new single-page application in React. Let's see it in action. npx is NPM package runner. Create React app is a package name. React frontend is our project name. It will go ahead and create a single-page application. Also, it will download and install the packages, dependencies. It will take some time. App is ready. Let's go into the project folder. It generated package.json and other subfolders like src public. We will look into them later. Okay, let's start the app. We see the Create React App homepage. All looks good. Terminate the process by Ctrl+C. Terminate the job. Now we are going to make some code change. Open up VS Code. On the left side, we see the code structure just generated. We need to extend it to display a list of week plan, ideally in a reusable component. So let's go ahead and create a placeholder for components. Add a subfolder under src, call it components. I'm going to copy and paste some code I already done. Let's go through the code I just copied. In the components subfolder, I just added weekplans.js. Inside, a function component called weekplans is defined. It has one input parameter, which we are expecting is an array of week plans. In the method, we are using JSX, which is a syntax extension to JavaScript. First, we display a header, week plans at the top. Then we call map method of the input array, goes through each of the items to display a week plan in a card. In the card, we display the details such as title, start date, and so on. At the end, we expose this component to other modules. Let's have a look of app.js, a container for all other components. Import the week plans we just created. We use state to hold the data pending to be rendered. We use component didMount method. This method is executed immediately when the component is mounted. In the method, we fetch data from an URL defined by an environment variable. We will come back to this in seconds. Get the JSON content. Set the value of the state to the data. In the render method, we simply return the component week plans to be displayed on the page. Let's come back to the environment variable. We need to provide the actual URL. I already defined one configuration file, env.development.local for local development. Inside, the environment variable is already there. We need to give it a value. It should be the URL of the function endpoint. Let's paste the URL here, save the change. One more thing, we go back to the week plans component we created earlier. We display each plan as a card. Actually, it's a bootstrap card. We need to add a reference to bootstrap CSS library. Go to public folder, open index.html. I already added a link to bootstrap CDN. Everything is ready at the front end. Switch back to the command line share. Start the app. Now we see the header with plans on the page, but there is no data. Let's open the developer tools. There is an arrow with CORS, cross-origin resource sharing. The reason is that by default, CORS is not enabled in functions. So let's copy this origin and enable it at the function side. We switch to the function project. Open the local configurations for functions, local.setting.json. We add a new property host. Enable CORS for the origin of our front end. Now we have localhost 3000 enabled for CORS. Save the change, restart the function. When the function is ready, we switch back to the browser, close the developer tools, reload the page. The data from the function is displayed on the page. Now we have a single page application running at the front end, a function at the back end responding to HTTP requests. The front end fetches data from the back end and displays them on the page. We are ready to move on to the next video. Thanks for watching.